want to introduce ANOVA, analysis of variables, or analysis and interpretation of what? Your regression equation, or interpretation of your regression what? Equation. Interpretation. A regression who? Of regression output, of regression output. That is what I want us today, or in this moment, to talk about. The first method that you use to interpret your what? Your regression equation is what we refer to as economic plausibility. Economic who? Plausibility. Economic plausibility here simply explains or asks the question, is there a logical economic sense? A logical economic what? Sense. What do we mean by a logical economic sense? This equation here, is it true that the material handling cost can be affected by your number of orders economically? Is it also true that your material handling cost can be affected by the number of kgs? That is what we refer to as what? As economic plausibility, where you're simply asking yourself, is there a logical and defensible relationship between the dependent and independent variable? Is there a what? So the question is there a logical and what? Defensible relationship between who? X and who? Y. X is who? X, remember we've said it is your independent variable, and Y we've said is your dependent variable. Okay. Once you've realized that, the next method that we tend to what? To use to evaluate regression equations is specification analysis. Specification analysis. And with specification analysis here, you simply look or analyze at the factors affecting who? Factors affecting or the assumptions of a regression. You analyze the assumptions of regression. For example, one of the assumptions of regression is that it is normally what? Distributed. So number one is that the error term is normally distributed. That is the first assumption. Is normally distributed. That is assumption number one. Number two, the second assumption is the assumption of what? Linearity. When we say linearity there, is there a linear relationship between what? The independent and dependent what? Variables. Is there a linear relationship between the dependent and the dependent and independent what? Observations. Number three is that there should be no autocorrelation, or there should be no serial correlation. No autocorrelation or serial correlation. What do we mean by that? What we mean is that the dependent variables x1 and x2 should not be able to influence each other. They should be independent of each other. They should be independent of each other. Then number four is multicollinearity. Multicollinearity there simply means that observations and error terms are independent of each other. Observations and error terms are independent of each other. Then finally, the fourth one or the fifth one is relevant range. relevant what? Range. What is the relevant range there? Relevant range, it assumes that linearity has a certain range where it holds. Linearity has a certain range where it does what? Holds. All right. That is what we refer to as specification and what? Specification analysis. Specification analysis. Let's go to the third method. The third method of interpreting what? Regression output is what you have here. The residue using the residue regression and what have you. We normally have two items that we analyze. In one, we analyze two items known as number one, goodness of fit tests for whole equation, for the whole what? Equation. Then goodness of fit tests, and the measures here, let me just highlight the measures. You have number one, correlation, standard error of estimate and coefficient of determination. So kuna coefficient of determination. Coefficient of determination is denoted as R squared. We'll talk about that in a few. Number two, standard error of who? Of estimate, which we simply denote as SE. Then the third one is Fisher statistics. Fisher statistic. Fisher statistic. Fisher statistic. And let me highlight these items using this question here. Let me highlight these items using this question here. Now, coefficient of determination number one, coefficient of determination which is R what? Squared, simply explains or simply states or measures the extent to which the dependent variables are affected by the independent variables. So it simply explains the causes of the changes in Y that can be explained by the changes in what? X. So it explains the reasons that Y, or the causes, or let me just state it here, it explains the variability or changes in what? Y that is caused. That is caused by changes in who? By changes in X. And remember, Y is what? The dependent, then X is dependent. X is dependent. For example, if we go to this question, before we, let me give you the formula. R squared is N summation XY minus the summation of X multiplied by the summation of what? Y. And summation X squared minus the summation of X square. You introduce Y, and summation Y squared minus the summation of Y, you do what? Square. But all that you do what? You square. All right, let's go to that April 20 what? Our April 2025 question 4. Our April 2025 question 4. Allow me to draw a table here. There was another table that we should have drawn. Please allow me to do away with this. Allow me to do away with this. Already we've done everything, so let me do away with this. There was another table known as the summary of output. Summary of who? Output. Have multiple R, which is 0.999420, R square 0.998841, adjusted R square 0.998509, standard error 75.76272. The number of observations in total are 10. Alright, so let me use this question to show you how you deal with R. Now, using this April 2025, question what? That was question 4b. R squared, you can say, R squared, you can say what? That R squared is 0.998841, which you can further say is what? 99.8841%. So you can say, you can explain and say that the changes, that 99.8841% of changes in who? In Y. Y was your who? Y was your material cost. Yes, Y was your material cost. Y, material cost, material handling cost, is costs by changes in x1. X1 was the number of what? Orders, and x2, and x2 is a what? X2 was your number of kgs, number of kilograms, number of who? Kilograms, number of kilograms. All right, now this we have done away with that question. If you go to a second illustration, December 2024, December 2024, question what?
1b,
Part 3 actually. They are saying the coefficient of determination R squared has been determined to be 0.913. So R squared here is what? 0.913. Therefore, you have it as a percentage and say it is 91.3%. Then you explain and say that 91.3% of the changes in who? In Y, and your Y was overhead costs. Overhead cost is cost by changes in X. And what was X? X was your equivalent production units. Equivalent production units. That is how you interpret R what? Squared. Coefficient of determination. Coefficient of determination. Let's go to that is the first measure I have talked about, R squared.